There you go.
Thanks, Will. We were in the back room getting ready for this, and Will said, "This is so light and breezy," and I said, "Until I get up to speak." I have to come clean. I am in the College of Natural Resources, but I was in the College of Textiles for 20 years, and my daughter's currently a student there, so go College of Textiles. I'm here to talk to you today about a passion of mine, and the beginning won't be so light and breezy, but I hope by the end you're thinking, yes, this is a great concept and it can work. My real passion is in global health, and since my expertise is I have degrees in biomedical engineering and textiles and polymer science, so most of my career has been focused in the area of textiles as health interventions. And I started off working in medical protective clothing and chemical biological protective clothing, but about 10 years ago, I saw that there was a need to start working in what I considered a space that there hadn't been enough attention paid to, and that's in the area of textiles for protection from vector-borne diseases from insects. Next slide. So many people don't realize that mosquitoes are animals, and they are, unfortunately, the deadliest animal, responsible for hundreds of thousands of deaths each year. The majority of mosquito-borne disease that kills people is malaria. Luckily, this number is coming down, largely because of the expanding use of insecticide-treated bed nets and also residual spraying, indoor residual spraying throughout the world. What you may not know is that the only mosquitoes that actually bite humans are female mosquitoes, and they do that to get enough energy to lay their eggs. The mosquito that transmits malaria is called Anopheles gambiae. And I'm not an entomologist, but I work with some pretty good ones, so I'm learning these terms. And Anopheles gambiae only bites at night. So that's why bed nets are so effective at curbing the spread of malaria. But what about mosquitoes that bite during the day? About 10 years ago, when I started working in this area, I started envisioning, would it be possible to start developing some clothing that could actually protect people from mosquito bites? And would it be possible to develop that clothing without the use of chemicals that are typically neurotoxins to insects that could have negative effects on human health? And people said to me, well, what difference would that make? The Anopheles gambiae mosquito only bites at night. And I said, well, you don't know what's coming down the pike. Next slide. So sadly, we now do have this epidemic that has infected millions of people around the world, the Zika virus. Zika is transmitted by a mosquito called the Aedes mosquito, and there are two different ones, Aedes aegypti and Aedes albopictus. And Aedes aegypti and Aedes albopictus are already established throughout the southern United States and all the way up the East Coast to about New York, New England. And this is a map of some of the cases of Zika virus that have already occurred, with the darkest colors representing the most cases. I think I read today that the estimates are that in Puerto Rico, very shortly, 1 in 4 people will be infected with the virus. If you don't know, not only is the virus transmitted by mosquitoes, but it's also sexually transmitted. It can be transmitted between a male and his female partner and can infect an unborn child. And the virus is passed between the mother and her fetus and results in severe birth defects. And we're just really starting to learn about the effects that Zika has on adults. And I recently heard a statistic that there are 82 pregnant women in Florida who have tested positive for the virus. So we really need something for these people. Next slide, please. So unfortunately, the market for this technology for protective clothing from insect bites is really enormous. Pregnant women around the world are being told to apply DEET to themselves sometimes 3 or 4 times a day. And they really are not, many of them are not comfortable with that. We really don't know completely understand the risks. And because of people's aversion to using these chemicals, they may be increasing their risk. Next slide. When you look on Amazon for insect protective clothing, this is what you might see. Clearly, this is not designed for the market that we are interested in. Not only that, it really doesn't work. If you do want to get protective clothing from insect bites, most of it is treated with some kind of a chemical repellent. Much of it is not, it may repel mosquitoes, but eventually that repelling can be washed out, leaving the person more vulnerable. Even clothing like this that's touted as bite-proof often is not effective. The insects can bite right through it. Everything we've tested in our labs over in entomology, insects can bite through. Next slide. So our solution is non-chemical bite-proof clothing, and it should look something like this and not like the previous slide. It should be economical and environmentally sustainable, and most of all, affordable and accessible. Next slide. So how do we do it? We are investigating 2 strategies. We've been working on this project for 5 years. The first strategy is to design fabrics that don't allow the little stinging part of the mosquito, which is the proboscis, the needle part, to penetrate through the fabric. Now you can say, well, I could have like this kind of solid film, and that's going to prevent the mosquito from poking through, and I'll say yes, but that won't be very comfortable to wear. So how do you design something with really tiny holes that's still really comfortable to wear? The second strategy is to design a fabric that does allow the little stinging proboscis to penetrate, but it's sort of thick enough that the proboscis can't reach the skin, and it's open and porous enough that you get good airflow and moisture vapor transport. Next slide. So this is an example of an ultra-thin fabric that's a knit, which would have very thin pores, fine pores. Next slide. And this is a little video clip that shows us testing. We have the fabric, a very thin knit fabric that we've designed, overlying a certain reservoir of blood, and the mosquitoes are trying to poke through it to get to the blood, but they can't. Next slide. And here's an example of the second type of fabric that we're working with, which is a moderate thickness fabric, which is extremely porous. It has 2 sides that are joined by another layer. And this is, if you go to the next slide, you can see a little video clip. Here you can see how open and porous and breathable this fabric is. It's almost like a gauze. But the mosquitoes keep trying to get through it, but they don't stop because they can't reach the blood on the other side. Next slide. Unfortunately, as I was saying, the size of this market is really huge. About a month ago when I started looking at the actual size of the market, I was thinking that if we just focused on Latin American women of childbearing age, that's about 150 million women. In the US, we have about 75 million women who fall into that age group. And remember, men can transmit Zika virus as well to their partner. I want, unlike Beth, I'm marketing to the masses here. So I want this to be like mosquito nets. I want everybody to have this clothing. And this clothing should look like every other clothing. It should be fashionable and comfortable. Everybody should have it, but it may as well protect you from mosquito bites. So assuming that we have 3 outfits per person, we're talking about, and this is the part Beth's not gonna like, is $10 to $15 per piece of clothing, because I said I want everybody to have this and be able to afford it. We're talking about an $11 billion market just in Latin America. Next slide. So our initial focus, we're working with some companies to develop an actual line of clothing. We're looking at these sustainable, non-chemical, and here's a really important point, culturally appropriate clothing and fashionable clothing for women who are pregnant. And we really want to work with people who are in the countries that are affected by Zika, not just in the US. Next. So we're focusing on this superfine knit fabric that we have, and we're looking at creating a garment a design that creates sort of a double layer of fabric to add additional protection for both the mother and the fetus. It has to be comfortable, and it should be fashionable. Here's the fun part, the fashion starts, so next. So the current product in the maternity market has very limited body coverage, which offers limited protection, and there's not a lot of great style here. And style is not my area, and I'm very conscious of my shoes right now. Next slide. My colleague, Andre West, who's a textile designer, faculty member in the College of Textiles, is standing over there, so I'm gonna go to him with any questions about the style. But we're looking at inspiration from existing products like a wrap dress. Next slide. These are some of the concepts that we have for the double layer garment, and in the tests we've done in the lab, these offer 97% bite protection. So we've put Andre in a room, we dress him up in these clothes. It's a big cage full of mosquitoes, this is the truth. And then we count how many, we collect all the mosquitoes after a few minutes and squish them to see if they've taken a blood meal. It's very high-tech stuff. And then count the number of welts on Andre. Next. So that's all I have to say, and again, I'll defer the fashion questions to Andre.